look at piecewise functions. Okay, we talked about what they were. They are functions that are defined for different pieces of the domain for by different functions. Okay, so the first thing that I always do is I just put where my breaks are. I have a break at 1. So I have a break at x equals 1. I know I'm going to change functions there at x equals 1. I know I'm going to at x equals 3. And then I'm going to end at x equals 5. And I'm going to end, so I'm going to end at x equals 3, 4, 5. I'm going to stop here, and I'm going to stop at negative 3. Okay. Now, I'm going to break these down into the different colors again. So I'll make this the purple function. Now, the first thing that I know about this is at negative 3 is going to be an open circle, and at 1 is going to be a closed circle, and then a line in between. So I just need to find what those points are and then connect the dots. So if I have my x and negative 2x, if x is negative 3, negative 2 times negative 3 is 6. And if x is 1, negative 2 times 1 is negative 2. And that's all I need to draw a line. So I know at negative 3, 1, 2, 3, 4, 5, 6, there's an open circle. At 1, it is negative 2, and that is a closed circle. And then I can connect my dots. All right, for this function, I know I'm going to have an open circle at 1 and an open circle at 3. This is a constant function. Where y equals negative 2. So that means I go from here to here, and I don't include either endpoint. Now I'm doing this in color so you can see it, but don't worry about it if we can't tell if they connect, which part of it is filled in and which part of it cannot. Okay, so here I've got a filled in circle at negative 3, an open circle at 5. So let's find out what those endpoints are since it's a line. So if I have my x and I have my x minus 5, if x is 3, 3 minus 5 gives me negative 2. If x is 5, 5 minus 5 is 0. So I have the point 3, negative 2, and the point 5, 0. And that's an open circle. And I connect my dots. Okay, let's do another one. All right, we're going to follow the exact same process. My purple function, I have an open circle at negative 5, a closed circle at 1. So x and negative 2x minus 2. So if x is negative 5, negative 2 times negative 5 minus 2 gives me 8. So the point negative 5, 8. And let's see, at negative 1, I have negative 2 times negative 1 minus 2, which is 0, so negative 1, 0. Okay, so negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's up here. Goes off the graph a little bit. Open circle, and then negative 1, 0. Now notice on this one, I didn't draw the lines because it's helpful to me, but it doesn't necessarily help you, so, all right. Okay, this function, again, it's a constant function. It has an open circle and an open circle. And again, this includes everything in between. Okay, so the points I've got, so I've got x and 3. So if x is negative 1, y is 3. If x is 2, y is 3. So I go 1, 2, 3, open circle, 1, 2, 1, 2, 3, and connect my dots. And then for this function, I've got a closed circle here, connects to a closed circle here. So let's look at x and negative 2x plus 1. When x is 2, negative 2 times 2 plus 1 gives me negative 3. So I have the point 2, negative 3. At 5, negative 2 times 5 plus 1 is negative 9. So I have 5, negative 9, and it's going to go off the grid. Maybe I should have scaled them by 2, but I didn't, so I'm not going to go back and do it. All right, so here I have 2, negative 3, 1, 2, 3, and that is a closed circle. And then I have 5, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be down here somewhere. And I connect my dots. So if we want to find the average rate of change, what do we do? Well, we basically are finding the slope. So we need between 2 points. So the first thing I'm going to do is find f of x1, which is f of negative 2.5, negative 1.7 times negative 2.5 minus 4.3 equals negative 0.05. So that gives me the point negative 2.5, negative 0.05. Then I'm going to find f of x2, which is f of negative 0.2, or negative 1.7 times negative 0.2 minus 4.3, which is negative 3.96. So that gives me the point negative 0.2, negative 3.96. Now I use my slope formula. I'm going to find the slope of that line. So the average rate of change equals the slope of the line equals y2 minus y1. So negative 3.96 minus 0.05 divided by x2 minus x1, negative 0.2 minus, this is going to end up being plus. Subtracting a negative is plus, 2.5. And when I do that, I get 1.7. I ran out of room, so you'll have to double check it on your calculator. Okay. Now, another way of wording the question exactly is I want to find the rate of change of this on an interval. That means I need to find f of -3, and I need to find f of 1. So that's 2 times -3 squared minus 3. So that's 18 minus 3, which is 15. So I have -3, 15. This is 2 times 1 squared minus 3, which is -1. So I have the point 1, -1. So I have to find the slope, which is -1 minus 15 over 1 minus -3. That's -16 over 4, which is -4. Okay. On this graph, it says that here's what it wants us to do. We want to find intervals of increase or decrease. Okay, so increase. And we're looking for the values of x where this occurs. So it is increasing, the function is going up from -infinity to -2, and it's increasing again between 0 and 3. So between -infinity and 2, it is increasing, and between 0 and 3, it is increasing. And remember, the corners or the endpoints, I don't worry about those. Okay. All right, then decrease is where it's going down. So it's going down from left to right between -2 and 0, and then from 3 on to infinity. Okay, so my relative max, or let's do a relative min. Peaks and valleys. So I have a relative min here. Okay. At x equals 0, there is a relative minimum of 0. Then we have our peaks. So at x equals -2, you have a relative max of 2. And at x equals 3, you have a relative max of 3. Okay. Let's see how far we can get in this before I need to switch videos. All right, the algebra of functions. Okay. So you're given 2 functions here, and we want to find all of these. All right, I'm going to try to write little so all of this will fit in here, but if I need extra pages, I will. Okay, f over g of x, of course, means f of x divided by g of x. which is x squared minus 1 over 2x minus 15. There didn't give you a specific value for x, so you're done. Okay, f minus g of 2 is the same thing as f of 2 minus g of 2. Now, there are a couple of ways that you can do this. You can either combine the functions and then substitute in for 2, or you can find f of 2 and find g of 2 and subtract them. Okay, so if I want to find f minus g of x, then that's just x squared minus 1 minus 2x minus 15, which is x squared minus 2x plus 14. So f minus g of 2 is 2 squared minus 2 times 2 plus 14, which is 14. If you want to do fg of 4, again, there are a couple of ways you can do this. This really means f of 4 times g of 4. So I would find f of 4. So f of 4 gives me 4 squared minus 1, and g of 4 is 2 times 4 minus 15. That gives me 16 minus 1, which is 15. 8 minus 7, I'm sorry, 8 minus 15 is negative 7, which is negative 108. 105, sorry. Got a little carried away there. All right, also remember that f dot g of 5 means f of g of 5. So what that means is I want to find g of 5 and then plug that into f. So g of 5 is equal to 2 times 5 minus 15, which is 5. Negative 5, sorry. Then f of negative 5, because g of is equal to negative 5 squared minus 1, which is 24. Okay, and I'm going to quit there.